Are you trying to build generative AI applications with your own data? apiRAG solves the problem of augmenting large language models with your own data in a way that is simple, efficient, and secure. So you can build generative AI applications that combine the general knowledge of LLMs with the specific information in your data. For example, suppose you work at a bank and you want to build an AI agent that can answer customers' questions about their transactions and analyze their spending. So a customer would log into the website and ask questions like, show me yesterday's transactions. apiRAG on the server side, which runs in the background, picks up that question, calls the API, and returns the information to the user. And I can ask questions like, what was my spending over the last 10 days? apiRAG coordinates the retrieval of information from the API, and then the information in this case gets plotted because the LLM determined that it was best to visualize that data for this particular customer question. Now we can see here that it is visualized from from most recent to last recent. I want it the other way around. Again, that gets fed back into the LLM, and the LLM will determine what the best way is to satisfy that request with the retrieved data. And as you can see, it turns the x-axis around. With apiRAG, it is simple to write these types of chatbots because you can reuse your existing APIs and only have to write a simple configuration file to securely connect your API to your LLM. Here's how apiRAG works. An apiRAG deployment consists of 4 components. First, there's the client, which for our demo was a simple HTML page that had some JavaScript in it to call the server and visualize the results. The file is in the repository and you can modify it to your liking. Most of the magic happens on the server here, which uses the apiRAG library to coordinate between the API and the LLM. For the demo, we embedded apiRAG into a Spring Boot application, and we used a locally running GraphQL API to retrieve the data, and we used OpenAI's GPT model as our large language model. apiRAG is a library that is configured through a single JSON file, which determines the mapping between functions and API calls, so that the requests from the LLM for additional information can be translated to the API. And here's how that works at runtime. When a client asks a question, apiRAG forwards the questions to the LLM for question analysis. The LLM then responds with either a function call to say, hey, I would like additional information to answer that question, or it produces a response if the question can be answered with the information the LLM has encoded in its training data set. Now, for the former case, apiRAG then forwards the request to the API and which returns the API response with the data. apiRAG then embeds that data with the question, forwards it to the LLM, which produces the final response that is then processed and returned to the client. As you saw in the demo, apiRAG has the ability to either return textual answers as is, or have the LLM tell it that it would like to visualize the data, in which case it returns a structured output that can then be rendered as a chart on the client. That was a high-level overview of apiRAG. You can find the code for the library, the example I showed, and additional examples in the GitHub repository. It's open source and free to use. If you have a little more time, I'd like to show you why apiRAG is a great choice for augmenting LLMs with your data. The RAG in apiRAG stands for Retrieval Augmented Generation. That's a mouthful used to describe a category of techniques for pulling in relevant information into the context for the LLM to provide better answers to user questions. So how does apiRAG compare to other forms of retrieval augmented generation. So generally, retrieval augmented generation works as follows. A client submits a question. Then on the server side, the question is translated to a query that is forwarded to a database. Usually the question is translated to a vector embedding and then forwarded to a vector database to retrieve documents that are semantically similar to the question. Those documents are then embedded with the question and fed into the LLM, which returns a response relayed to the user. Now, standard RAG approaches have the downside that they don't quite know what information the LLM actually needs to answer the question. They make an educated guess, so to speak. They look at the question and then either use a form of keyword extraction, so they can use search, or they use vector embedding, so they can use semantic search to find related documents. But with standard RAG, you don't actually know whether those documents are the documents the LLM actually needs in order to answer the question. And so RAG is often extended to a pattern called flare, which basically extends the standard RAG retrieval with an additional step that after the response given by the LLM, on the server side, you analyze the result token probabilities to find areas where the LLM was uncertain about its response. So basically, we look at the response and can identify mathematically what sections of the response the LLM wasn't quite sure about. And then we formulate queries both based on those sections, feed them back into the vector database, retrieve additional documents to ideally augment those specific areas that the LLM wasn't sure about, feed that back into the LLM to produce the final response. The reason for this more complex form of RAG is to use feedback from the LLM in order to find better, more relevant documents to augment the context and produce better answers. With apiRAG, we don't have to do that because we forward the question immediately to the LLM, and the LLM basically tells us what the information is that it needs. And so when you look at when should I be using apiRAG, basically if you want to generate high quality answers, apiRAG can give you better guarantees because the LLM will guide you, so to speak, on the information that it needs to produce high quality outputs. In that way, it is also more efficient because the LLM can tell you exactly what information needs to be retrieved from the API, and you don't have to guess as to how much data to produce and put into the context of the LLM. apiRAG works particularly well on structured or semi-structured data because it allows the LLM to push filters into the API so only the data is returned that's actually relevant to the user question. Like in our demo, when I asked for the spending over the last 10 days, the LLM was able to identify that time period and only data from that time period was returned, not all customer transactions. apiRAG works really well with existing APIs and therefore allows you to reuse infrastructure you already have to augment your LLMs with custom data. And it allows you to build a modular infrastructure by separating the data backend from the AI application and build a microservices-oriented architecture. When should you not use apiRAG? apiRAG does not give you much benefit over standard RAG when you're working with unstructured data, because there is not a lot of structure that we can extract or that the LLM can use in order to fine-tune the type of information that it needs to retrieve. It also adds additional latency because we have to do 2 round trips to the LLM, first to analyze the question and then secondly to produce the final answer. So there is an additional latency and with that also associated an additional cost. Now that said, compared to more complex forms of RAG like the flare pattern that I described, it has the same latency and cost footprint because in both cases you're doing 2 round trips to the LLM. To summarize, apiRAG is a great choice when you're dealing with semi-structured or structured data and want to produce high-quality answers efficiently. In addition, apiRAG is pretty simple. It's a lightweight library that you can embed in the server framework of your choice, and there is a single configuration file to configure how the API is mapped onto function calls for the LLM. Oh, and 2 more things. First, apiRAG supports secure sandboxing based on session context, so the LLM can only access data for a particular user or session, and there's no risk of sensitive data exposure. Second, apiRAG also makes it easy to save and retrieve a user's message history, so you can pick up a conversation where it left off. So this is the overview of how apiRAG works. There are additional steps that are optional for saving questions as they come in and retrieving the history, so we can look up previous questions and add them to the context so the LLM knows what the user previously asked about. apiRAG then coordinates that with the API to save messages and retrieve messages from the API. So it modularizes the backend from the actual AI application. Similarly, it will persist the response that the LLM produces and save that message so it can be retrieved as part of the history in a future interaction. We hope you find apiRAG useful as you build your AI applications. If you do, give it a star on GitHub. And if you want to make it better, we'd love for you to contribute to the project. Thank you.